Hello guys, hello world, hello Philippines. I'm back again with my live streaming. How are you guys? Are you okay? So, okay, let's go back with the discussion of ideal gas law. Okay, so we need to recap the different equations and formulas of ideal gas laws. Okay, before we solve the problems. Okay, later because we solved already, I think, three problems out of seven problems. Okay, so wait for a while. I have to get my questionnaires. Okay. So, if you are staying with me right now, it could really recall your stack knowledge regarding chemistry, especially for the topic of gases. Okay, specifically the ideal gas laws. Okay, so this is very important, especially in the power plant industries like that, nuclear power plant, really, electricity or electrical power plant, something like that. My gosh, wait for a while. Okay. So, hello guys. Thank you so much for watching as our viewers now. Watching right now. Okay. Thank you so much, guys, for looking and take a glance of my live streaming on the spot conversation and discussion. I don't even plan this to have live streaming because I'm singing a while ago a couple of songs and enjoyed a lot, and then I want to break the monotony. Wow, break the monotony, or so that I can have another avenue of, you know, what do you call this one? Pastimes. Yes, pastime like that. Okay, wait for a while. So September 2020 will be intended for all days will be intended for chemistry. Okay, we will be talking about gases, solids, liquids, chemical reactions, something like that. And we need to discuss also some portions of the gases, the inert gases, the transition elements like that. Okay, the radioactive because in terms of examination, yes, examination talaga siya. Okay, in high school, high school chemistry, right? My gosh. Actually, it's just the same in college chemistry, but there are a lot of additional only, but still the same. I think so. Okay. Still, it will be applied there, and then some topics will be discussed also. Model of iPhone, the first parent model of all the iPhones is iPhone 4S. Okay, I have to connect it to the internet so that I can also play watch hours in my videos. Oh my God, your connection is unstable. Please wait while reconnecting. Oh, really? My gosh. Thank you so much, guys. Oh my gosh, Floor Ashu, mega mega shout out to you, and Mom Lezeline 34. Oh my gosh. Okay, sige na, maglapagan na kayo dyan. Wow. O, di ba? Like this. Oh, so I have to, like this, I have to click your name and then I will put you as a moderator. This, okay, like this. Why? Why, Delilah? Okay. Hi, Ma'am Lizalane. Okay. My first love is singing. Okay. Like that. Okay. When I was a kid, and then when I grow up, singing is my first love. And also, speech is my second love. Speech meaning to say, I could speak extemporaneously to everybody, okay, like that. Do reporting in school, like that. Okay. I can do also, I can also join oratorical contest, declamation contest, something like that. When I was in college, I even joined essay writing contest when I was in college also. Okay, so I love English too much. Okay, and then actually, best chemical engineering is not my first course I planned when I was in college. It's actually Bachelor of Science, Mass Communication major in broadcast journalism. Really, that's my first intended course. But my scholarship, okay, but my academic scholarship, presidential scholarship, it is not included in my the list of courses that I will be able to take up. That's why I choose engineering, and there's a lot of choices for engineering: electrical engineering, civil engineering, mechanical engineering, and chemical engineering. But since I love chemistry too much, I love physics and chemistry, then I choose chemistry. So in love with chemistry because the world is made of chemistry. Okay, everything we breathe through gene that God gave us freely in order we can survive to this contemporary world, right? Okay, that's freely, okay, free, okay? God's computation of gases reactions or gas one, molecular weight, okay, and atomic weight, molecular weight. Anybody? I'm lecturing, my gosh. Okay, okay. Okay, I would just like to talk to you. It's better to share that to everybody since I don't share to everybody my, my education is an elementary, high school, and and college like this. Okay. In elementary, I was not an honor student. In the grade 6. Okay, hello, Mom Flora Show. Diba, elementary have grade 1, grade 2, grade 3, grade 4, grade 5, grade 6. Okay, I was an honor student when I was in grade 1 up to grade 5. Grade 6, when I was in a graduating class, I was not able to become an honor student. Because I made mistakes. Charot. I say actually, but I really have a great argumentation with those teachers in my elementary education, like that. Because I was a kid, okay. Then I'm very, very, very talkative, like that, very energetic, like that. And always playing games, something like that. And I don't like that. Okay, and I was pulled down in my values education and what do you call that one? The other subject, the GMRC, the good moral, GMRC, good manners and right conduct, something like that. We always proceed in the ground, something like that as well. Okay, something like that, and came to a point that I was able to be an honor student in grade 6. The same as also in high school education also. I am a consistent honor student when I was in first year until third year. But in a graduating class, I was not able to because there's a certain rule, something blah 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 and so on. So I was awarded only as an academic excellence, bronze academic excellence when I was in high school, okay? Like that. In college, oh my God, so many, so many intelligent people are there. The competition is very tough. Okay, so many, because we need to compete with other engineering courses also during the rankings. Okay, but in our course, I could land to within the top five, top 6, something like that. I play around on that portion. Something pulled down, and sometimes I will not be on the 10th list, but sometimes also come in, sometimes come out. So not consistent anymore. Okay, my God. And you know why? Because I'm not good in mathematics. I'm just an average regarding mathematics. Because engineering has so many mathematics, okay? I will tell you, algebra, trigonometry, geometry, differential calculus, integral calculus, differential equation, advanced engineering mathematics, probability and statistics. Okay? So many mathematics are there, and then so since I'm not good at mathematics, and my grades are being pulled down. Okay, with those subjects, even though I'm okay, not really that good. I'm okay in sciences, but it's pulled down. Sometimes I will never be in the dean's list. Okay, but sometimes be there. Okay, sometimes not there. Like it's not consistent. Okay, like that. Okay. Aba, may pa-jacket. Oo, kasi pinipress ko. Nasapit na po ang dila. I was pressing the moderator. Sorry, if I will speak in Bisaya Tagalog, I will be able to speak fluently. Okay, but I will speak in English, I can manage well speaking in English. Okay, I wonder why, my gosh. I wonder why. Okay, like that. Thank you so much, Ma'am Lizalyn, for sparing your time. There's no other people here right now. Okay. Yeah, they're coming now. Okay, Ma'am Lizalyn, are you interested with chemistry subject when you are in college or in your high school? Okay. Are you interested for that? Okay. Until now, I love examinations, really. Okay, until now. Maybe I don't have my own family, then I still have to read, research, okay? Then I don't have my own children, that's why I focus still on the, information. Maybe if I have my own family, I can forget those basic lessons when I was in elementary, high school, and college. But still remain in my brain. Oh my gosh, remain in my brain, something like that. Okay? So, we reviewed now the constants in ideal gas law. As we can remember, we have the R, the universal gas constant, or the ideal gas constant, okay, which is 0.08206 liter atmosphere per mole Kelvin. Remember, in PV and RT, ideal gas law, the temperature is always in Kelvin. Okay, now, if the problem stated there, degrees Celsius and degrees Fahrenheit, then you have to convert that with Kelvin. And you know the formula of Kelvin in basic chemistry? It was discussed in high school, right? And then up to college, it was also discussed. Kelvin, or the temperature in Kelvin, is equal to degrees Celsius plus 273. Now, if the Celsius is given in the problem, you can convert that directly to Kelvin. And if it is stated in degrees Fahrenheit, you can also compute that through changing that first to degrees Celsius. Because the degrees Kelvin has no degrees Fahrenheit immediately in the formula. So you need still have to convert the degrees Fahrenheit into degrees Celsius so that you can insert that in the formula. Degrees Kelvin is equal to degrees Celsius plus 273. Okay, Ma'am Lizalyn? It's chemistry, basic chemistry. Okay. I use microphone because the sound of the laptop is not really functioning at all. Okay? Unlike using mobile phone, if I stream live in my mobile phone, it is okay because the sound, the internal sound of the mobile phone is functioning. While on the laptop, the internal sound is not functioning. That's why I use this Bluetooth microphone. Okay? Stay with me. Okay. I have, oh my gosh. So this is not a declamation contest. This is not an expository speaking contest. This is not a speech contest. Okay, this is just only. Okay, I solved already problem number 1, problem number 3, and problem number 6. Okay, and yesterday I live streamed yesterday. Okay, so the problem number 1 talking about the ideal gas law using the equation PV is equal to nRT, pressure times volume, is equal to the number of moles times the universal gas constant R times the temperature in Kelvin. Okay, take note, Ma'am Lizalyn. Kelvin is not degrees. Only Celsius and Fahrenheit are degrees. You will only say that as Kelvin. It's not degrees Kelvin. Okay? For example, 42 Kelvin, 50 Kelvin. It's not 42 degrees Kelvin. Only Celsius and Fahrenheit, you have to talk with degrees. Okay? Like that. 22 degrees Celsius, 42 degrees Fahrenheit, but it could never be 42 degrees Kelvin and 52 degrees Kelvin because Kelvin, it's not a degree. Okay? Very clear now? Even though before I also confused for that, and I keep on reading different textbooks when I was in college, in the library, because I spent most of my time in the library, okay, when I was in college, okay, like that. Okay, now we go to problem number three. The problem number three is related about Avogadro Law. Okay, the Avogadro Law. It is the only gas law that involves the relevance of the number of moles of the quantity of a substance in the reaction of gases. N is equal to the number of moles or the amount of substance. So, for example, if there is a question in chemistry that states that what is the unit of amount of substance, the answer will be mole, M-O-L-E. Again, what is the unit of amount of substance? So it is mole. It is not gram, it is not liter, it is not atmosphere, of course. It is mole, M-O-L-E. So mole is the basic unit of a substance in chemistry. Okay, we can put that in our brain and in our mind wherever we go. So we will, meet the moles on the road or whatever. Okay, something like that. Okay. Now, number six, also we saw that already, right? Number six, don't be confused in the ideal gas problems or gas problems because mentioning partial pressures, that could mean Dalton's law of partial pressure, okay? Sometimes, for example, you'll be given a problem and then so many pressures and you will be confused. So if there is a word partial, that could mean, this is Dalton's law of partial pressure because it mentioned about partial, okay? You should also consider English in problem solving. That's why I told you a while ago, that if you have a clear comprehension in English, you can understand also what is being required on the particular problem, especially problems that involve deeper terms like that. It will sometimes be inserted in the problem. Then if you don't have great knowledge in English, then you will be confused sometimes. You cannot understand also what is being required, what is being asked on that particular problem. You will be confused sometimes, only sometimes. Okay, if you refer on the different textbooks in the library or even in Google Chrome or Google, okay, in the www.net, something like that, internet, there are still deeper terms that have so many synonymous terms. And then sometimes it will be inserted in the problem and you don't know what to do. What's this all about? Don't tell me you will be able to find in a dictionary during the examination. No need. No, your time will be consumed. So all you have to do, if you read some information in the net or in any textbooks or any reference information guide or any relevant sources of information, you have to research what's the definition of that particular terms in which you did not understand, okay? I mentioned that already to you in my previous live streamings, right? So that you can understand that in the next reading or, encountering that words, not unfamiliar words, sorry. Those are unfamiliar words, something like that, okay? So it's common in journalism, so many words, and then you have to go to another synonymous words, and then basically it has a common word. For example, rampant. Rampant means common, okay, and widespread, meaning it is usually used, okay? If I will say, ideal gas law equation is very rampant in chemistry, so I'm talking that this ideal gas law is very common. And then somebody could not understand what is rampant, and then you have to go to the dictionary, okay, like that. So as early as possible, you need to consult Webster's dictionary if you encounter very difficult terms in certain articles, columns, any textbooks, and everything. Okay, and you have to be, read, because the world makes round if you read, and search for information. Okay. Because not all the time we will refer to Google, because, for example, if you are walking to the road or you are in the particular venue for a certain examination or whatever, don't tell me you will find data there and research for Google. No more time. Okay, that's why you need to consult while you are not yet in the examination or in interviews, employer interviews, or whatever or any endeavor that you are going to undergo, then you have to refer to the dictionary like that, blah, 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 so and so, okay? But the problem is more of us don't love English, okay? That's really true, okay? Only few love English subject. Okay, but I love English so much. I love science and English. Okay, that's right. If you combine English, science, and mathematics, then bingo, you have passed the examination. Really. Okay, because most of the examinations are science, English. Okay, you can understand or comprehend properly the problems. Logical comprehension of English grammar, something like that. Not only grammar, the words, spelling, and everything. Okay. Oh my God, why I'm talking about English? Because I love English. Okay. Number two. Hello, Ma'am Liza Lane. I will be able to discuss to you number two, number four, number five, and number seven. Okay. Number two. Problem number two. Oh my ganon. How many grams of carbon dioxide should be placed in a 250 ml container at 24 degrees Celsius to produce a pressure of 95 kilopascal? Oh, really? Okay. This is on the spot. I did not solve this. Okay. I did not prepare this. I just write the best problems that I am going to share with you. Even me, I was confused at first reading. How many grams of CO2 should be placed in a 250 ml container at 24 degrees Celsius to produce a pressure of 95 kilopascal? So we need to examine the problem. There's a lot of properties involved, right? There are volume, there is temperature, and there is pressure. Basing to that, what particular ideal gas law equation that mentioned so many variables and properties of a gas? It could either be the combined ideal gas law or the combined gas law or the ideal gas law. Okay? Now, if we take the combined gas law, okay, there's no final and initial state of the reaction because it's always P1, D1, progressive like this, but there's no initial and final. So it could be the basic PV and RT that we'll be able to use. Okay, PV and RT only, only like that. Okay, so it's not also Avogadro law because number of moles are not being mentioned. Okay, it's not also Dalton partial pressures because partial pressures are not being also mentioned, right? Very clear. It's not Charles' law. It's not because there's the initial and final volume and temperature. It's not also Gay Lussac's law because there's no pressure and temperature initial and final state. It is not also Boyle's law because there's no initial and final state or pressure and volume. So the safest way is to use the ideal gas law, which is PV is equals to P in R. PV is equals to nRT. Now I will get the. Oh my gosh. We will solve this in actual. Oh my gosh. I will get the pencil pen. I have a green pencil pen here. Oh my gosh. And I need to get the scratch paper. Okay. I will just imagine that I am your instructor in a certain university. Oh my gosh. Like that. Okay. I love also, I have the passion of teaching because I took up masteral course in University of San Carlos before, Master of Science, major in environmental science, but I did not finish, I did not complete that one. Okay, but I already experienced also, subjects in masteral, but I did not finish it. But at least I experienced how to do reporting in a masteral students, like that, blah, 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 so on so. Okay, in masteral courses, you will act as a professor also, and your instructor will be the student. Reverse, okay, again, in masteral courses, that's in University of San Carlos, Cebu, Talamban, no. Yeah, Cebu City or something like that. The instructor will just give you the topic, something like that, blah, 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 so and so, like that. And you will be able to research that one and give to the students, and the students will discuss on the front of or listening, and the instructors will listen to you, and you will be the one to discuss. The students will discuss and do the report, and then the instructors will just listen to it. Because all of you are already professionals, okay? And then you will be the one to discuss to him or to her, and he will just listen and just correction, like, no, like this. And there will be an interactive discussion between you and the students and your classmates and your instructors. That is in masteral education. Okay. And luckily, I did not finish that one. Okay. That's why I'll never put that in my resume because I'll never finish that one also. Okay? Like that. Okay, that was Master of Science major in environmental science. I took up that one because it's related to HSE, Health and Science and Environment, Health and Safety and Environment. Okay, that's why. Because I plan to teach safety engineering or occupational safety and health in college. Because there are now courses, oh no, not courses, subjects of occupational safety and health in engineering. All engineering courses have a subject known as occupational safety and health or safety engineering, something like that. Subject already. Before there's no subjects like that in safety, but now as I look their prospectus or their curriculum is already safety, occupational safety and health, blah blah blah. Okay, industrial safety, safety engineering. But that engineering is not the course, only subject. Okay, just like biochemical engineering. Okay, biochemical engineering is a subject for chemical engineering, something like that. It's also the same thing with sanitary engineering. It's only a subject for civil engineering, something that I'm not really sure for that. It's only a subject by the civil engineering course. Am I correct? I'm not a civil engineering graduate. I am not a civil engineer. Okay, but I think so. Oh my gosh, sanitary. Oh my gosh. I'm talking about water like that. Okay. Okay. I will now take the hello, Ma'am Flor Ashu. Akro or Ashu? Okay, I will get now the paper. Oh my gosh, talking too much. Hello. Gosh. So I'm afraid that the microphone will be low bat because I was seeing a while ago and then it's becoming low bat and I charged it. Okay. Wonder why. So I think this is not very comfortable discussing with you guys because I don't have the whiteboard or the blackboard to discuss it properly. Okay, and I don't have the stand of the camera to, to give a very beautiful, angle of my discussion. It's very clear. I'm standing and discussing to you properly like that. There's no such whiteboard and blackboard here. Okay, so I will get the paper now. Gosh. Scotch paper. Oh. Hello world, hello Philippines. I am here, Journal Voice, streaming live all about chemistry. Okay. Actually, I forgot the definition of chemistry, but what I understand is a combination of chemical processes like that, laws and principles that undergo changes. So, like talking about chemical changes, chemical reactions, so those are chemists, right? Because I know physics. Physics is a branch of science that deals with the study of matter and energy. Okay? I'll never forget that. Okay? If we speak about physics, the law of Isaac Newton are very important. The first law of motion, okay? The Isaac Newton's law, third law of Isaac Newton's, first law of Isaac Newton, the second law of Newton, and the third law of Newton. The first law is talking about the law of inertia, right? So, as far as I could remember, my stack knowledge, law of inertia, whenever a force is applied to a certain body or object, it will not continue moving unless applied by a net force, something like that. It's always applied with a force in order that object to move. Okay, that's law of inertia. The second law is talking about the law of acceleration. Okay, law of acceleration is equals to, based on my stack knowledge, is equals to the mass times, okay, the mass times the force, something like that. I forgot. Okay. Or force is equals to mass times acceleration. It's like that. Just review that because that was too long ago. Okay. Force is equals to mass times acceleration. Try to multiply the unit of mass to acceleration. If it cancels out, and the unit will become Newton. The unit of mass is gram. And the unit of acceleration is meter per second square. Acceleration in physics. Yeah, meter second square. So if, oh yeah, force is equal to mass times acceleration. Because if you multiply mass, grams, convert that in kilograms, okay, times acceleration, meter per second square. Now, remember, the unit of Newton is equal to kilogram, meter per second square. So that is force. Yes, I did it. Okay? So that's stock knowledge. So the second law of Newton really is equals to force. Force equals to mass times acceleration, where force unit is Newton, okay, and mass is in kilogram, and acceleration will be in meter per second square. So kilogram meter per second square is equivalent to Newton. Perfect. So that's the second law of Isaac Newton. The third law will be the law of interaction. Okay, whenever there's action, there must be an equal and opposite reaction in physics. That third law of motion is very important in physics, very basic. Okay, like that. You will compute the motion, the projectile, blah blah blah, so on so on. You will enjoy. Okay, solving the distance, the velocity, the acceleration, the momentum, like that, the velocity, blah blah blah, so and so. Okay. And you have to compute sometimes the circular conference, like that. You have to also recall the algebra, right? And you also incorporate that in physics. Okay? That's the reason why there's prerequisite. Because that prerequisite in college, blah blah blah, okay? If you don't know about algebra and trigonometry, it's applied in physics and you will be nothing in taking up physics. Okay, because the surface area are being mentioned also there. Okay, the volume, blah blah blah, circumference, what else? Volumetric flow, volumetric flow. May ganun ba? Okay, okay. Why too much talking? Okay. Hello guys. Okay, I will now write. I cannot leave the microphone more like this. Okay. Carbon dioxide. As far as I could remember without locking the periodic table, okay, so if your course is BS Chemistry, Bachelor of Science in Chemistry, or Bachelor of Science in Chemical Engineering, okay, the basic elements are already stacked in your brain. Okay, the most common elements, molecular weight or atomic weight will be stacked on your brain. Okay, then if you don't do that, you are not a real chemical engineer, or not, you are not a real chemist, something like that. Of course, you are not real if you do not pass the board exam, something like this. Okay. Okay, carbon dioxide, carbon 12. Okay, 12 is the atomic weight of carbon. Okay, and oxygen has a 16. As far as I could remember, oxygen, the atomic weight is 16. So since there is 2 atoms of oxygen, moles of oxygen, to multiply by 16. So 32. 2 times 16 is also 32 plus 12 is equals to 44. So the molecular weight of CO2 is 44 grams per mole. Okay, I will write CO2. My gosh. 44 grams per mole. Okay. And then you can relate that immediately to the molar mass. Okay? Molar mass. You know molar mass because in terms of mole, the numerator is grams and the denominator is mole. So, by word alone, it is molar mass. Okay? Okay. Molar mass. What is the formula of molar mass? Okay? So, you have also to think that if you multiply that with the mass, it will become the mole. Something like that. Okay, you will only just recall the basic, and then you will apply that in per mole. Okay, and then in a 250 ml container, so I have the volume of 250 ml. Milliliters. Okay, milli. What in mathematics is milli? Okay, times 10 to the negative 3. Okay, stock knowledge, milli, because the mega is 10 to the 6. Okay, something like that. Yeah, I think so. Giga is 10 to the 9, something like that. Okay. You also remember the prefixes, huh? In mathematics, very important. Example, giga, mega, pico, nano, centi, DC. Very helpful also because problems also don't mention the exact figure. Sometimes they will mention only the 2 decimeter like this, and you have to convert that in meters. So there's a DC. So you have to convert that to meters. So if you don't recall the basic conversion factor, and you'll be in trouble. It's okay, problem. Because conversion factors are understood to be memorized. Because we cannot convert conversion factor, is already standard, being discovered by the scientists. Okay? Like that. It should be memorized. Okay? Unless your examination is open book. Then you can go over. But it's still wasting of time just to get the conversion factor of decimeter to meter, pressure, atmosphere to torr, okay? Bar to blah, blah, blah. Then you have to memorize. Okay? Because that's only very basic. You can encounter that in the future, blah, 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 so and so, especially in the real world. For example, in industry, in the power plant, the unit of pressure is very important also. It's labeled there bar. When you don't have an idea about bar, compute that to atmosphere, like that. In your mind only, something like that. And then you can compute the flow, okay, the flow of a gas inside the pipeline, imagining something like that. Imagining the flow of the gas inside the pipeline. You can compute that one, okay? And then you have the molecular weight of what particular gas is inside the pipeline. Okay, di ba? Enjoyable. Oh my gosh. Okay. Okay. Now going back, I have the temperature. Temperature is 24 degrees Celsius. Okay. Guys, I don't have to state to you who discovered degree Celsius, blah, blah, blah. Degree Celsius is, I don't have to do that. You should also research that one, because I'm only telling the direct formulas and the direct principles and theories. I don't have to go to who discovered blah, 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 blah. No, it's not like that, because it should be your own effort to do that. I'll tell you frankly and honestly, in college, they will never mention that one, okay? They will never mention too much in the discovery, in the processes. I have my own initiative to do that in the library. For example, who discovered hydrogen? So it's Henry Cavendish. Who discovered oxygen? It's Joseph Priestley. Who discovered penicillin? It's Alexander Fleming. Who discovered vulcanization of rubber? Is Charles Goodyear. Something like that. So it's discussed a while ago in chemistry, but in college they don't go over that detail. They were focused on the problem solving, really. All about math, and then some principles, like that, and very fast, discussion, because the instructors will assume that the students are also good. Because you reach that level, college education, so he or she expects that you have a better comprehension every time she or he will discuss in front of you. But the truth is, not all can understand immediately what the instructor are really talking about. Okay, my style before, I'll never question the instructor, and I will just go to the library to clear that out in my mind, something like that. I will consult also to, to higher class. For example, if you are second year college, you will consult to third year college. Why like this? Well, and then like that. Okay, 24 degrees Celsius. Okay, and the pressure will be in kilopascal. Don't be afraid with kilopascal, because you think, what's that all about? Don't be afraid with that kilopascal. It's kilopascal, that means it is automatically pressure, right? It's just using the kilo. Again, prefixes in mathematics. Kilo is 10 to the 3, so 3 zeros. Okay? That's why 1,000 grams is equals to 1 kilogram, because kilo represents 3 zeros. Okay, that's only prefixes used in mathematics for the purpose of easy to write and easy to understand or easy to recall with. Okay, like that. So in our PV and RT, okay, the standard form, the units. Okay, after obtaining the required or what is being asked, here what is being asked is how many grams of CO2? Oh my gosh. Normally, if the student is not really quick on his mind or in her mind, he will be afraid already because PV and RT has no mass in that equation. Okay? Again, normal student, not normal, most of the students, including me, okay, we will be confused if there's mass in grams already because in PV and RT there's no such gas there in terms of grams. So do not be afraid. Just connect the basic formula in each property. Okay. So we have PV and RT. So we have the grams of CO2. Okay. But volume, okay, in chemistry, basic concept, density is equal to mass over volume. Okay. And you can compute for volume. Okay. Like that. And you can compute for mass. And you know, if you know the density of that gas, then perfect to a certain temperature also, right? And then another, we can get that through the molar mass by obtaining the molecular weight, and then you have the number of moles. Then perfect, you can get the mass. So there are two versions how to get the mass. Okay, so it's very clear now, huh? Very clear how to get the mass. It could either by using the molar mass formula, by the determination of the molecular weight and the number of moles, okay, or in the equation of the density is equal to mass over volume. Okay, since the problem doesn't mention the density of a gas at a certain temperature, so it is not valid for that. We will use the molar mass because originally all gases has its own molecular weight. Okay, then we can use that immediately because there is number of moles in the PV and RT. Okay, like that. So grams of carbon dioxide, do not be afraid. Okay, you also before afraid. My gosh. Okay, like this. Okay, PV and RT. My gosh, PV and RT. Okay. The pressure will be in atmosphere. We go now to the agreeing meaning consistency of the units. Most of the students sometimes will fail to get the correct answer because their units are not consistent with each other. They'll just substitute immediately the units in that equation without knowing that it's incompatible with each other. Then you have to convert that one to have the same unit from the left side and to the right side of the equation. Okay, like that. You have to agree the units. Okay, then you have to convert that one. Do not substitute along the numbers, substitute it with units to make it easy to understand, something like that. Here, the given is 95 kilopascal. It doesn't agree with the basic unit of the pressure mentioned in the PV and RT because it's usually in the atmosphere. You know why? Because the universal gas constant or the ideal gas constant involves atmosphere in the numerator. Okay, that is 0.08206 liter atmosphere over mole Kelvin. Okay, so atmosphere is very important there. Kilopascal is equal to atmosphere. Okay, in this manner, you have to consult the books or the Google, something like that if you don't know the value. But as I said you over and over again, you have to memorize that. Even if you love science courses, then better start memorize that in high school or in elementary so that when you go in college, you will be stacking that in your brain already without going back to the books and going to the Google. Okay? 1 kilopascal, how many atmosphere is the 1 kilopascal? Okay, 1 atmosphere is equal to 101.325 kilopascal. You should put that in your brain, okay, in your mind. Retain that in your mind. Again, 101.325 kilopascal is equals to 1 atmosphere. Do you have your paper? Just write down. Okay? Like that. This is very basic. These are very basic in sciences courses. You have to memorize really. Okay, 1 atmosphere is equals to 101.325 kilopascal. 1 atmosphere is equals to 101,325 pascal. Okay, 1 atmosphere is equals to 764 TORR. Okay, 1 atmosphere is equals to 760 millimeters mercury NNHG. 1 atmosphere is equals to 14.7 pounds per square inch to the PSI. Okay, 1 bar is equals to 14.7 PSI. And now you can convert that somewhere along the way, and you can get the atmosphere unit in the ideal gas law. Because atmosphere is the standard unit in the ideal gas law, something like that. Then if your units will be agreed, then perfect. You can get what is being required, and it cancels out upon plugging that one. So 95 kilopascal, 101.32 kilopascal to 1 atmosphere. I have the calculator. I can compute with my brain. I have to use the calculator. Okay. We can compute only in our brain addition and subtraction. Usually, sometimes multiplication, but division is very difficult. We can use really the calculator for that, right? I am correct. But if you are really super intelligent, then you can calculate that with your mind. Then it would be better. But there's no such super intelligent. Okay? Or intelligent. We are just average. Okay? All people are just average. It depends on the efforts. Okay? 95. Okay? Oh my God. Time check is brought to you by Powder Glass Top now. 96.3 W-Rock. Oh my gosh. May kantahan pa in fairness. Okay. Like that. 75. Substitute that one. I don't have to put atmosphere because it's already atmosphere converted already to save the space for the paper. Oh my gosh. 0.9375. The volume given is 250 ml. Since the R, or the constant, universal gas constant or ideal gas constant, is in liters, okay, then you have to convert that milliliters to liter. So basic again. 1 liter is equal to 1,000 milliliters. Okay. Oh my gosh, what's happening? 1,000 milliliters is equal to 1 liter. Okay. That could be 0.250. Okay, without using the calculator. Yes, because if zeros involving numbers with zeros, as far as I could remember in mathematics, you could only be moving them to the left, moving them to the right, without using the calculator. And okay, substitute that here. Okay. Number of moles. Okay. The R will be the 0.026, right? Because it agrees with the liters of the atmospheres. I don't have to put the units anymore because it's agreed already. So 0.08206. You can also use the other universal gas constant, or the ideal gas constant, is equals to 8.3147 liter kilopascal per mole Kelvin. Why will we use that one? Because there's a kilopascal. Why? So anybody can answer? Actually, you can use that also. It depends on you during the conversion. Okay? Like that. And the temperature in Kelvin? Oh my God. You know, the problem is using units. All of them will be converted first before inserting to the original ideal gas law equation. See? The author of that problem is really trying the student to think deeply what that, if he really understood the problem or the principles behind ideal gas law equation, something like that. He really measures if the students are really doing his best or her best to research more, if it is not only a word for word substitution or like that, then you have to think and to go farther beyond that, something like that. See, all will be converted first before inserting to the ideal gas law. Oh my gosh. Okay. So Kelvin is equal to degree Celsius, which is 24 plus 273. Okay, like that. Okay, 24 plus 273 is equal to 297. Okay, and now perform the basic mathematical operation. Oh my ganon. Mathematical operation. Okay, 0.93. Actually, basic mathematics are being involved. It doesn't involve calculus. It doesn't involve differential equation nor advanced engineering mathematics. It's only basic mathematics, plus, minus, multiply. It's the way how you interpret and the way how you understand the problem with its principles and laws and equations involved in that particular problem. Something like that, okay? 0.9375 times 0.250 is equal to 0.2, oh my gosh, 344. And then 0.08206 times 297 is equals to 24, oh my gosh, may ganon, 37182. So compute to the number of moles N. N is equals to 0.2344 divided by 24. What's that? 37152. Okay. 0.0096. Okay, let's review. Our number of moles is 0.0. Before multiplying that moles to the molecular weight of carbon dioxide. Okay? Because through multiplying the molecular weight of the particular element or substance or compound, whatever, you can get the molar mass. Something like that, okay? So moles. Let's review first, because without review, you will be wrong. Okay? Just like doing an article in journalism, you have to proofread your articles. You have to check the grammar, the spelling, the organization of the phrasing of your sentence, like that. Okay, to avoid redundancies, something like that. Okay, 0.9. Oh my gosh, 9375 times 0.250 is equals to 0.2340. Okay, and then 0.0806 times 297 will be equal to 24.27182. Okay. Malabo na yung mata ko, in fairness. Okay. And then, 0.2344 divided by 24.37182 will be equal to 0.0096. Okay? Really easy if we have the formulas and equations in our mind. Something like that. Okay? 24.37182. Oh, so we have 0.0096 moles of carbon dioxide, and you have to multiply that with the molecular weight of carbon dioxide. Okay, then you can get the mass. What is being required in a particular problem? Something like that. Oh, diba? May ganun. Okay, then 0.0096 will be equal to times 44, like that. Okay, that's the answer. 0.0505 grams. Okay, the answer is 0.0505 grams. Okay. There will be 0.505 grams of carbon dioxide to produce in that problem. Okay, number 2. How many grams of carbon dioxide should be placed in a 250 milliliter container at 24 degrees Celsius to produce pressures of 95 kilopascal? Okay, the answer will be 0.505 grams of carbon dioxide. Okay, I'm tired, so I think we will not continue the other problems. I'm tired of talking. Oh my gosh, something like that. Yeah, if you really love the topic and then you can discuss it well, if you have the passion in delivering that information to, the viewers or whatever, then it's gonna be a smooth discussion, something like that. Oh. Okay. Oh my gosh, what's happening to my phones now? Oh, wait for a while. Something. Whether we will go also to the, what do you call that one? Nuclear chemistry. Do you love nuclear chemistry? It's all about, proton, electron, neutrons, positron, like that, and the atoms, the nucleus, something like that. Electrons will be in the outer shell, the protons will be inside the nucleus, something like that, and you have to add the protons and electrons, blah, 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 so on and so. Okay? That would be nuclear chemistry. Okay? That's also interesting, right? We speak about nuclear. Oh my God, interesting. Too much. Okay, an orbital like that, SPDF. You know SPDF orbital like that? SPDF, something like that. Okay? The quantum, the magnetic quantum number, the ganon. Okay, the quantum mechanics or quantum physics, something like that. I forgot. Forgot. Okay, that's it. So actually, we have still 3 problems for the ideal gas law. Okay, number 4, number 5, number 7. Number 7 also is, I think so, it's ideal gas law. Okay, it states that 56 grams of nitrogen and 96 grams of oxygen gas are mixed in a 2-liter container of 300 Kelvin. Okay, calculate the partial pressure. Oh, partial pressure is Dalton's law partial pressure, right? Of each gas and total pressure. Ah, so many required. The partial pressure of oxygen gas and the nitrogen, and then the total pressure also. Ah, it's interesting. Okay, total pressure, as we can remember, I discussed it yesterday. The Dalton's law of partial pressure is equal to the total pressure is equal to partial pressure of A plus partial pressure of B plus partial pressure of C. Okay, and the mole fraction represented as X is equal to the number of moles of A over to the total number of moles, and the mole fraction of B or XB is equal to NB over PT. NB is the moles B, okay, and T is the total number of moles. Then mole fraction of C, XC, is equal to the number of moles C and C over the total number of moles. Okay, so that's the 2 equations already. What is the 3rd equation? 3rd equation will talk about the pressure fraction. And then in Dalton's law of partial pressure, by theory and principle, the mole fraction and the partial pressure fraction is equal. Okay, so it has the same formula, the same concept. Okay, so our XA also, which is equal to the XA or in terms of moles, would be equal to XA PA over PT. It's in equilibrium. You know equilibrium? It's the state, the initial and the final state will be in equal, or the reaction, the reactance rate of reaction is equal to the product rate of reaction without adding heat and oxygen, something like that. Okay, that's equal. That's in a state of equilibrium. So that's a steady state equation. Okay. So it's stable already. So meaning to say, the number of moles in the left corner is equal to the number of moles, total number of moles in the left corner is equal to the total number of moles in the right corner. The left corner are what we call as reactants, and the right corner is what we call as the product, something like that. If that does not equal, something wrong with your equation. That's why you need to balance the equation, or balance the chemical equation, so that you can compute properly what is being required in a particular chemical reaction. It should be first balanced above all. Okay? Like that. So 56 grams on N2 and 96 grams oxygen. Okay, that's Dalton's law of partial pressure. So we have now the two formulas, right? Then number 3, okay, XA PA over PT. What's PA? Oh, partial pressure of A. Don't be confused with ABC. ABC is just a hypothetical values. It doesn't mean it could be various gases involved. Okay, it could be the nitrogen, oxygen, argon, the noble gases. You know the noble gases? Or the inert gases, the krypton, the neon, the xenon, something like that. Those are noble gases and inert gases that will not react to any elements. Okay, if you react that one to a metal or a solid, it will never react because it's inert. It has no reaction at all. It will always split in the reaction. Inert gases or noble gases, except for the non-noble gases and non-inert gases, still like oxygen, okay, nitrogen, those are not inert gases. Okay, the inert gases are those on the other side. Okay, that is krypton, neon, xenon, something like that. Those are noble gases or inert gases, including the argon. Argon will never react. There's no such argon dioxide, there's no such like that, okay? There's no calcium argon, there's no like that. Meaning to say that it will not react to form as a compound because that is inert or noble gas. So argon, krypton, xenon, and neon are non-reactive to elements. They will never form a compound if you added that to any elements in the periodic table. Okay, it's unstable always. Argon, krypton, neon, and xenon. Okay, sometimes the problems will confuse you like that also, sometimes in the problems. Okay, then you will be confused. But in theory, it will never react, something like that. Okay, so here, mentioned in number 7 is are not inert gases. Okay, this is monoatomic gases. Monoatomic meaning one atom. Okay, monoatomic gases, because based on the theory and principle, okay, ideal gas law is applicable only to monoatomic gases, preferably at highest temperature and lower pressure, something like that. Actually, okay, that's what the principle is all about. We don't have to prove that one. We can only prove that one through laboratory experimentation in chemistry. Everything can be proven to laboratory in experimentation. This, it will never become a law. It will never become a law or an equation if you will never test that to laboratory. Okay? That's why we verify that in the laboratory experimentation. Before those scientists will declare that as a law and having an equation, then it should be first undergo to laboratory tests to prove and confirm the behavior and properties of those elements that they are discovering. Okay? Like that. Okay. I don't have to compute this one. It will take too long. Really sure. Okay? Like that. That's the fourth formula, right? The total pressure, the mole fraction in terms of number of moles, the fraction in terms of pressure. So that is pressure fraction. Sorry for that. That's pressure fraction, not mole fraction. Okay? Pressure fraction. Because I was confused because using the same variable x for that. You can use x because, as what I mentioned earlier, that is equal by principle and theory. Okay? For the purpose of understanding only. So that's x, the same thing. Okay? Like that. And the fourth formula for this is the, okay, total number of moles. Na plus Nb plus Nc, or N1 plus N2 plus Nc, like this, okay? Total number of moles. Then you can substitute the mole fraction and you can get individually, blah, 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 so on. So, Okay? If you can understand it, you can easily get the, what is being required, something like that. But we'll solve this tomorrow. Okay? Tomorrow talaga. And then we have the number 5. It looks like a long problem. Okay. A 200-liter container holds 0.650 moles of helium gas at 37 degrees Celsius at zero pressure of 62.3 torr. See torr. Okay. What will be the new pressure of the container in atmosphere inside the container if the new volume is reduced to 120 liters? The temperature is increased to 177 degrees Celsius and 125 mole of additional HE gas was added to it. It looks like very complicated, right? And there's so many given. And then, so what will be the formula for this? Okay, there is a volume, there is an N, there a number of moles, right? There's a temperature. Okay, so the identification for this new pressure, new volumes, it is understood that there will be an initial state and the final state, initial phase and the final phase. So because of the new pressure, what will be the new pressure? So there's an initial, right? So it could be using either, so Dalton's law of pressure will not be used anymore, and the ideal gas fluidity factor will not be used anymore for this. It could be the Charles law, the Boyle's law, Avogadro law, and the Gay Lussac's law. I think so. But if you can notice, a lot of variables or properties being involved. So it's gonna be the combined gas law. Okay? Well, I'll tell you frankly for this. Okay, in our chemistry, when I was in high school, and even in college, it was not discussed. Oh my gosh. Really, because the instructors are not telling you to spoon feed, because you have the efforts to do so. You will go to the library if you cannot understand what he or she is talking about. You can ask her directly during her or his discussion on the class. Okay? But my strategy is different. If I don't understand, I will take that down in my notebook and I will go to the library directly during my break time. Okay, like that. So it's different strategies and initiatives by the students. It's up to you. Okay, as long as you will verify that one, why it goes like that, how it can be like that, like that. Okay, in combined gas law, there are 2 equations. But as far as I could remember, in college and high school, it was discussed only one equation. As I become older, older talaga siya. Okay, when I grow, when I go in the higher chemistry, not higher chemistry, when I was in 5th year, 4th year, like this, I researched and I found out another equation, even though it was not discussed by the instructor. Take note, okay? I really found another equation that involves the number of moles. Because most of the problems of combined gas law, the number of moles doesn't have an issue, because it states there that the molecular attraction and the molecular sizes will not matter. It will be negligible. It doesn't consider that much. Okay, that's why they automatically cancel the number of moles in that particular combined gas law. But if there's a change in the quantity or the amount of substance in the initial state to the final state, then you have to include the number of moles, because the problem states the number of moles. Then you will never force that other equation that there's no number of moles, and you will be confused also in the problem solving, because it's not being discussed with your instructor. So how can you do that? So it will create confusion because there's a number of moles, okay? Like that. So all you have to do is to insert the number of moles. Hello? This it was not discussed in college. It was not discussed in college talaga. Okay. Okay, there are two versions of equations, right? P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. And the other equation of combined gas law is equal only eliminating the number of moles, P1 V1 over T1, like this, okay? Then P2 V2 T2. Okay, no number of moles. But in here, there's a number of moles. Then you have to insert this in the equation. Okay? So that's it. Substituting that one by one, and we can get the what is being required. Okay? So the question states, what will be the new pressure of the... So P2. Okay? What is the new pressure? Meaning final pressure, right? Okay, then you have to substitute that directly to the equation P1 V1 over N1 T1 is equal to P2 V2 over N2 T2 because there's a number of moles being mentioned in the problem. Okay? So the units will agree. Yes, the units will agree automatically. All you have to do is to think the units of the initial and final properties will agree or consistent or compatible with each other so that it will cancel out. Okay? So the question is, what will be the new pressure of the container in atmosphere? So since the question is in atmosphere, then you will be confused also because the atmosphere is in torr. Then you have to convert the torr into atmosphere later. Now, the tricky part also in examination or in board examination like this, they will insert the given here, okay? And they will also put that in the choices. For example, after the solution, I can get 20 torr, okay? When you substitute that everything, 20 torr is correct, really. Okay, and this A, 20 torr, A, 20 torr, B, atmosphere, like that. And then you will be confused, you will choose the torr, something like that. But actually, you will choose the atmosphere because it was being mentioned in atmosphere. Or sometimes, you get the value of 20 torr, but you will still use the 20 atmosphere. You will just try to trick you out to the choices. Okay, you for example, after the solution, your answer is 20 torr, actually. And then the choices is 20 atmosphere. So you will automatically choose the 20 atmosphere because it's the same figure. Okay, don't be confused with that. Because after that final solution, you still convert that to atmosphere, in which that it will no longer be 20. Something like that. That's only example. That's the tricky part of the problem solving or in any examinations. We will just convert that after that one. Okay? Thank you so much. Number 4, what's all about this? Okay. At 85 liters flexible container holds, what's this? An 85 liter flexible container holds 3.4 moles of gas. How many moles of gas should be removed to decrease the volume of the container to 40 liters? So this is also tricky. You have to analyze. Okay, you have to analyze 2 times, 3 times, or 4 times like this. Okay, so in this problem, volume mentioned, number of moles mentioned. So it's number of moles and volume are mentioned only. So there's no such temperature, there's no such pressure. So automatic, it is not the combined gas law, it is not the Dalton's law of pressure, it does not the Charles law, the Boyle's law, or the PV and RT. So you will use the Avogadro law, okay? V1 over N1 is equal to V2 over N2, in which volume 1 here, 85 liters, okay? And volume 2 is 40 liters. And we have the number N1 is 33.4 ml, and N2, nothing. But how many moles of gas should be removed to decrease the volume? So it should be X, number of moles total should be, let the value of X of the number of moles being decreased. So it could be X minus 34, because that's decrease, right? Minus. So N total, number of moles total is equals to N final minus N initial. So N final, let X is an N final. So X minus 3.4. The result of the equation, you can solve the value of X, and then you get the number of moles. Okay? Because how many moles of gas should be removed to decrease the volume, man? Okay? So So you have to say x minus 34 as your M2. It's not easy to understand if there's no whiteboard or any or paper. I'm tired also using the paper is also consumed. Oh my gosh. Okay. Thank you so much. It's already 1 hour and 17 minutes and 30 seconds. Okay. Like that. Oh. Nag-enjoy ba kayo for this ideal gas law problems? Actually, I love to solve the 4, 5, and 7, but I cannot discuss it well because I don't have the scratch papers anymore and I don't have the whiteboard to simplify the equations or so that it could be easily understood to the viewers or for the purpose of discussion, something like this. Okay? Oh my gosh. Guys, thank you so much for sparing your time with me for this chemistry ideal gas law problems or gas problems for this lecturing streaming session. See you next time for another chemistry topics. This is I am a singer, eternal voice. Just comment, like, subscribe, or click the notification bell for some updates of I Am a Singer, Eternal Voice. Bye-bye, babush. God bless everybody. Have a good time. See you later.